Okay, so I wanted to talk about two things with this example of a technology that's used for steel production. The first thing is about forecasting coil that have negative avoided emissions, meaning that the solution is actually worse, it generates more emissions than the baseline that we're using. And the second thing is to think about technologies that have to do with electrification and the choice of using electricity from the grid versus dedicated renewables for those types of solutions, and the large impact that can have on the final avoided emissions estimate. So this is an example. It's a technology called molten oxide electrolysis. It's essentially a technology that uses electricity to produce steel in contrast to more conventional steel production. And as you can see from the executive summary page, it has a pretty substantial negative impact given the kind of like uh, standard choices that we're using for this model. And when you have a negative avoided emissions, really the place you need to go to look at that, to interrogate that, is the unit impact. So if you have a negative avoided emissions, it's because your unit impact is also negative. So the solution is more GHG intense than the baseline. So to go take a look at this, for this example, we're going to click on the unit impact, and we can start looking more into the details. So there's kind of two reasons why this model has negative avoided emissions. The first one that I would look at is the choice of the baseline. And so if I just expand this here, I can get some more details on the baseline. And the baseline that's being used is primary steel production via the blast furnace, basic oxygen furnace pathway. And this is a really conventional steel production today. But the baseline that we're using is this SBTI aligned. And so we're assuming that there's some decline in emissions for overall steel production into the future. And we can actually see this more clearly if we scroll down to the bottom here. This bottom traces the baseline, and you can see that it's declining over time based on some alignment with SBTI guidance. And because our baseline is declining, over time, our solution never really catches up. It's never better than the baseline. So that's one reason why we have this negative avoided emissions. The other reason gets more into the solution itself. And so to see what's going on here, first I'd look at the value chain. So on the left-hand side, we have our baseline scenario. Again, it's primary steel production via this very conventional pathway. There's a few different phases: material extraction, materials prep, and then the two main kind of production phases, so iron making and then steel making. And then finally, there's some steel finishing as well. Now, if we look over at our solution, so primary steel production with this molten oxide electrolysis, we have pretty similar phases. There's material extraction, materials prep. In this case, then iron making and steel making are lumped together, and steel finishing. And what we can see is that this iron making and steel making phase is still quite large, and actually in the balance it comes out so that the solution in this case is more intense. So it has this 1.8 megatons of CO2 per megatons of steel, whereas our baseline has 1.4. And just a reminder, in this case we're looking at 2035, just because that's our the time frame that we've chosen is 2025 to 2035. Okay, so what's driving this large emissions intensity for the iron making and steel making in our solution? So now if we come over to the solution description, we can start to figure out why that is. So yes, this is production of steel via this molten oxide electrolysis. The molten oxide electrolysis produces this refined molten metal, essentially steel, that's ready for the steel finishing processes. And then this is kind of key. So the scenario assumes an electricity demand of 4 megawatt hours per ton of steel. And the emission intensity is calculated based on a global grid electricity emissions intensity. So what this is telling us is that for the solution, it's being modeled as electricity coming from the grid to make iron and to make steel during this molten oxide electrolysis process. And so it's that combination of a high electricity demand and a pretty intensive electricity emissions because you're just taking electricity from the grid, which is a mix of renewables and fossil fuel sources. And so we end up with this pretty substantial iron making and steel emissions intensity. And this happens a lot with some of these like electrification solutions where if you assume that you're just taking electricity from the grid, sometimes that actually outweighs the kind of improvements you might be expecting from electrification versus conventional fossil fuel based production methods. So one thing we might be curious about is, okay, so what if instead for this solution, we had some kind of dedicated renewables alongside this electrification process? So a bit good like back of the envelope thing to do is just to look at the phase that's using the electricity. So in this case, it's the iron making and steel making. And we can make just the really basic assumption that this would essentially go to zero if you have a fully dedicated renewable electricity source. Um, so in this case, this phase is around, let's say, zero point 0.9, zero point 0.8, something like that, megatons of CO2e per megatons of steel. And so if we go up to our kind of full GHG intensity, if we switched over to a dedicated renewable, then we might drop this number down to around 1 megaton of CO2 equivalent per megaton of steel. And so then that would actually be less intense than our baseline, and we'd end up with a positive avoided emissions value. So our solution would be lowering emissions overall. Okay, so that summarizes just kind of some of the reasons why you might find negative avoided emissions models, and in particular for those electrification solutions, how the choice of the electricity source is like a really key parameter in determining their overall intensity of your solution. Okay, so I talked about the like back of the envelope way to do that, but there's another way to actually interrogate this more thoroughly in Koi, which is to use the edit mode. So essentially to make a new solution GHG intensity that has these new assumptions about what is the electricity source for your solution. So just to show that off a bit, so first thing you need to do is to make a copy of this model. So I'm going to go over here to Actions and do Clone and Customize. That will allow me to make my own edits and make my own private version of this model. So I'm going to do Clone this model. I'm going to click Clone. Success. Okay, so now you can see up at the top here, there's this parentheses copy. So that's telling me this is now my private version of this model. I can make whatever changes I want and yeah, play around with this. So I'm going to go back to the unit impact and I'm going to switch into edit mode. So this edit mode here. Okay, let's start editing. I'm going to bring out these details again. And now here what I'm going to do is I'm going to duplicate this solution scenario and then make a few changes to it. So down here in the solution scenario, I'm going to say duplicate. It'll create a copy of the current solution scenario, which is exactly what I want. Okay, now you'll see there's this copy here. So now I'm going to go in and edit this. I'm going to rename this to say that this is via molten oxide electrolysis. And instead of using any grid electricity, this is going to be using dedicated renewables. Good enough. Okay, and then down here, I'll also just add this in the description. Emissions intensity is, let's say, calculated is assumed to be 0 from dedicated renewable energy electricity generation. Okay. So now the rest, the description I'm going to keep the same. Guess I'll just delete this part. Okay. So now if I scroll down, the rest of this I'm going to keep the same. That's all fine. So that's the description. So the other thing I want to edit is the actual value chain nodes. And to do that, I'm going to scroll down to my nodes here, and I'm going to go into the iron making and steel making, and I'm going to edit that one. And in this case, I'm just going to set these to 0. I'm going to assume that my renewable energy generation is approximately 0. There's obviously some for like upstream effects, but 0 is going to be a good first approximation. So set this to 0 also. Okay. So if I save this, what we're going to see is that this node is essentially going to disappear because I've set it to 0. And if I scroll back up, you can see that in the bar chart as well. And then if I scroll all the way to the top, you can see that the GHG intensity of my solution scenario has now been reduced, and it's actually lower than the baseline scenario. So if I go all the way back to the executive summary, now we're going to see my new annual impact, the avoided emissions, when I have this dedicated renewables alongside this electrification technology for steel production. Okay, and then I can just save this. Save as minor changes. It's going to reroute me to the new model. And so now I have this forecast for molten oxide electrolysis with the dedicated renewables. And with that, thanks for watching, and I'm looking forward to bringing you more KOI content soon.